Hello my dear viewers, welcome to this new video on eddy current testing and thermography. You are listening to me, Dr. Binia Rustan. Eddy current testing is an electromagnetic non-destructive testing technique which is primarily used only on electrically conducting materials. It makes use of electromagnetic induction to detect and characterize the surface and subsurface flaws in conductive materials. The eddy current testing is also known as inductive testing. The principle of eddy current testing lies on the basis of electromagnetic induction. In this method, eddy currents are induced in a test object by bringing it close to an alternative current carrying coil. These eddy currents are normally parallel to the coil winding. The defect in the test object impede and change the direction of eddy currents and cause changes in the electromagnetic field. These changes affect the inspection coil, the voltage of which is monitored to determine the presence of defects. The advantages of eddy current include it can detect both surface and near surface IR regulations. It is quick to use and provide immediate results of inspection. It is a versatile technique as it can detect flaws, variations in alloys or heat treatment, variations in plating, coating thickness, wall thickness and crack depth. No physical contact is required for this testing. It can be automated. It is of low cost and portable testing method. Pre and post treatment of the test object is not necessary in eddy current testing. The limitations of eddy current testing include the sensitivity response to a number of variables and interpretation may be difficult. Only applicable to conductive materials such as metals. The reference standards are needed for comparison. Highly skilled operators are required to perform inspection. It is not reliable on carbon steel for reduction of subsurface flaws and not suitable for large areas. Its depth of penetration is limited to 8 mm. No permanent record is available in eddy current testing. The constant separator distance between the coil and specimen is required for good results. Application of eddy current testing. The various applications of eddy current testing method includes detection and measurement of flaws in steering mechanism, airplane landing gears, engine parts, reactors, steam generator turbines, aircraft wheels, etc. Detection and determination of the severity of various surface cracks, weld seams, labs, pits, scabs, porosity, voids and inclusions. Measurement of coating and plating thickness. Detection and measurement of flaws in seamless, hot rolled steel tubes, welded tubes, fastener holes, etc. Measurement of dimensional differences in machines, formed and stamped parts. Determination of hardness and depth of case hardening in bearing rings. The next method is thermography testing. Thermography testing is a non-destructive testing imaging technique that allows the visualization of heat patterns on an object. thermography is also called as thermal imaging or infrared thermography. Thermography enables the thermal profile of material or component to be presented in a graphic form, which allows a working temperature assessment to be derived. From this, variations in the materials or component temperature are identified, using which the flaws or defects can be detected. Thermal inspection involves using contact and non-contact type heat sensing devices to detect temperature differences. The principle behind thermal inspection involves the measurement or mapping of surface temperature when heat flows from, to, or through a test object. The temperature differentials on a surface or changes in surface temperature with time are related to heat flow patterns. These heat flow patterns can be used to detect flaws of the test object. For example, during the operation of a heating system, a hot spot detected at a joint in heating duct can be caused by a heat air leak. The advantages of thermography testing includes it is carried out during normal operation conditions without stopping the system. The non-contact test method can be used from a safe distance. Visual picture of the components can be identified. Permanent record is possible. The results are available in real time and there is little or no processing needed. IR cameras are relatively easy to use. It can detect conditions of the equipment and defects before they become serious problems. The exact location of the defective zone can be easily identified. The limitations of thermography testing include interpretation of results need certain experience and knowledge. Higher accuracy of detection of defects can be difficult due to varying emissivity of the different materials. The comparatively cost of the equipment is high in thermography testing. The various applications of thermography testing include detection of defects in composites, inspection of impact damages in CFRP, detection of cracks in turbine components, detection of corrosion in aircraft parts, inspection of drilling induced defects in laminates, inspection of motors and rotating equipment, inspection of surface cracks in method structures, inspection of bearing wears due to misalignment. With this, we come to the end of this video. Thank you for the patient listening.